Okay, welcome back everybody. Now we're going to start talking about graphing radical functions. And the way I basically see this whole process is that if we're going to successfully graph a rational function, a radical function, what we're going to have to do is three things. Number one, we have to be sure what our domain is. And we just talked about that in the last two videos. We have to be able to find the ordered pairs that we need to plot our expressions. And then we want to fit one of the general shapes for either a square root or a cube root function. So let me first start off by showing you the cube root and the square root functions. And we'll start with the square root. That usually seems to be the easiest. The numbers that we want for x in a square root are going to be perfect squares if we want to get perfect or nice round numbers for y. So if we have perfect square numbers for x, then we'll probably do okay. So what kind of numbers are perfect squares? Well, certainly 1, right? If we choose x equals 1, and I'm just going to make a little table over here. If we choose x equals 1, then we might note that the square root of 1 is equal to 1. So our graph will include the point 1, 1. Okay? Now, if we put in 2, that's not going to work, right? Because 2, that's not a nice perfect square number, so we don't like that so much. But how about, what's the next one after 1? How about 4? Let's see, 4 for x means we'd be taking y as the square root of 4, so we're going to get y equals 2. So over here, if we go over to 4, we should get y equals 2. The next one higher from that would be 9. And if we put in 9, we're going to get 3 for y. So we'd come all the way over here and have the point 9,3, although it's not properly marked here, right? 9,3 would work, 4, 2 would work, so would 1, 1. Any others? Well, absolutely. You can put in 0, right? 0 works. As long as x is greater than or equal to 0, we're within the domain, right? So this is the idea that we want to make sure we know what our domain is so we can actually find an endpoint. And the square root of 0 is 0, so this graph will pass through the point 0, 0. Now, if we play connect the dots right here, this is the basic shape of our square root function, passing through each of these points as we go along, just kind of goes up slowly, curves a little bit as it goes down. This is the graph of y equals square root of x. Right? So we would use this basic shape now as a reference for any time that we're dealing with a square root function, because our square root function graphs will all look very similar to this. All right, how about this guy? Y equals the cube root of x. Well, this time we want some perfect cubes, and we're not limited to the domain of just greater than or equal to 0. Remember, if it's a cube root, it's an odd root. So our domain is going to be the set of all real numbers. All right, so what kind of perfect cube numbers do we know? Well, I'll make a little table over here on this side. This time, let's pick out a few candidates. I definitely know positive 1 is a perfect cube because the cube root of 1 is itself. Right, so this graph would certainly pass through 1, 1. Well, just like in the last graph, we said what would happen if we had 0. And the cube root of 0 is 0, right? Any real number works right here, so this graph will pass through the point 0, 0. We can even take the cube root of negative 1, because the cube root of negative 1 would be negative 1, right? Negative 1 times itself 3 times is negative 1. So this graph passes to the point negative 1, negative 1. Any more? Well, sure. What about 8? Cube root of 8 is positive 2. So this graph would pass to the point 8, 2, way over here. And if positive 8 will work, so will negative 8, right? Because we can put in any real numbers, so the cube root of negative 8 would be negative 2. So we go all the way to negative 8 over here, and we go down to negative 2, and there's our plot. And now if we were to ferret in the curve right here, this is what it's going to look like. Starting at 0, it'll shoot off to the right, kind of like the square root graph looks. But if we go to the left this time, it'll look like a reflection around that origin, and the graph would go off like this. So this is our basic graph for y equals a cube root of x. So anytime that we're going to deal with a cube root function, we can use this as our model to see what the rest of it's going to look like. Okay, not so bad. We need these two introductions. So let's get into our two graphs in the next video.